All right, students, welcome to Lesson 3 and 14 combined, Unit 8. Today we are going to go ahead and dive deep into rational and irrational numbers. Basically, we're going to categorize numbers based on certain characteristics. So, with that being said, let's go right into what we often do at the very beginning, and that is to check your homework in. So, please open up your workbooks and go to the previous homework, and you're going to see the answer key up on the board. The priority questions are going to be number 2 and number 4. So what I highlighted in number 2 and 4 basically go over the major things you should have responded on those, specifically how to take the square root of a number. If it's a perfect square like 2a, you would simplify it to 6. If it's not, like 2b, you would just say, oh, square root of 37, but it's between 6 and 7-ish. All right, so at any point, like I typically do in a lesson video, please go ahead and pause this video, check this over, okay? Your teacher should be walking around checking you in that you completed it, but otherwise, resume the video when everyone has completed their check. All right, so let's continue on from here. So you at this point should have your workbook open to 116, page 116. We're going into lesson 3 with a little bit of lesson 14 combined. All right, while you do that, okay, read or listen to the targets that we're going to discuss. So by the end of this lesson video or lesson day, you should be able to say, yep, I know what a rational number is and can give an example. And you should be able to say, hey, I know what an irrational number is and could give an example. So that's our targets for today. So let's go ahead and see if we can get this into some context. So we're going to go to section 3.1. It's on page 116. To start off, we're going to look at 4 equations. What I want you to do is take a moment and think, okay, answer each one of these 4. How can you figure out what x is going to equal? What x will be to get the number that it is after. So it says find a positive solution to each equation. Just give me a value of x that makes each of these equations true. Feel free to work at your shoulder buddy or the general people around you, but go ahead and pause this video and we'll come back together to discuss in a moment. All right, so magically the answer should pop up on the board, but what you should notice is that I have done all of them in fractional form. Some of you may have done the second one as 1.5 or the last one as some other type of decimal, but the key question here, oops, and I noticed I made a little mistake. Don't call me out on that, but look on the last one, it should be 7/5, not 7/25, okay? But the general idea here is you're looking for an x value that equals what is afterwards. And your number sense should come in strong here. Remember, I've talked to you about everyone here has number sense. It's like you inherently know what it is without knowing specific methods. Well, I'm going to show you a specific method. So let's start with the first one. So if you're stuck on any of these, let's see if we can get a method that will work. For the first one, x squared equals 36. In the previous lesson, we discussed how squared and square roots are inverse operations. So my goal is to get the value of x. So if I square root both sides, that is an inverse operation. And squared and square root cancel out. I'm left with x equals, and the square root of 36 is 6. That's a lot of work, okay, compared to most of you looking at something like that and say, oh, it's got to be 6. 6 squared equals 36. But this is the official work. When we do a problem with a fraction, it's a little bit better to see, okay, if you intuitively did not know for question number 2 that it was 3/2, that we can take the square root of both sides, just like I did in the previous, and it's a little more evident that, okay, if I take the square root, then I can take the square root of the top number, 9, which is 3, and the bottom number, 4, which is 2. And that's a little bit more obvious of what type of answer should have come from here. Even though it could be simplified to 1.5, I'll leave it as 3/2. So what's this all about? Well, if we go back to our target, I told you we're going to discuss rational and irrational numbers and categorize them. Everything that you just saw in front of you or did in front of you, these are rational numbers. They're rational because, well, let's put it this way. I'm going to give you the full definition in a little bit, but you should notice that these numbers are like really pretty looking. They don't have long, crazy decimals or anything sort. They simplify to a nice looking fraction or whole number. Well, rational numbers will have a very specific definition I'll go over in a moment, but basically you can see these work really well to define what general rational numbers are. So with that being said, and like I said, pause the video at any point if you need to, but I'm going to kind of move on from here. We just worked with some square roots that are perfect squares, things that you have worked with in the past. And now I'm introducing you the concept of, yeah, these are all rational numbers. They look pretty nice. They were easily calculated without having to have long, complicated looking decimals. All right, so we're going to do one more here. It's on page 117, okay? It says, which of these numbers are a solution to the equation x squared equals 2? I want you to try solving this, okay? So x squared equals 2. Which one of these would be the solution? Feel free to work with your shoulder buddy and people around you, but pause this video and resume it since it seems like everyone is at a good point. All right, let's discuss this problem. So we're trying to find, it says, which of these numbers are a solution to this equation? So let's go ahead and solve it using that technique I just talked about. Let's square root both sides. And if I do that, x equals, and I'm like, wait a second, I don't know a perfect square that's 2. That means I'm trying to find a number times itself that equals 2. And to be honest, it doesn't really seem to exist. So I'm going to test it out on a calculator. On your calculator, have it out right now. If you didn't get one, please go ahead and get one and pause the video. But I'm going to just assume you have one and kind of continue talking about this problem. So square root of 2. The square root button is right above the x squared. I'm going to hit second x squared, and it gives me a square root button and putting 2 in. And when I do it, it gives me a long, crazy looking fraction. I'm not fraction decimal. It's about, I'm just going to round it. Excuse that bell. About 1.4142. Oh man, it's very complicated looking. But the point here is that 2 is not a perfect square. And if I look at any of the numbers over here, well, let's convert these to decimals. It's pretty clear it's not 1. 1/2 is 0.5. No, it's not 0.5. 3/2 is 1.5. It's close, but it's still not exactly it. 7/5 is 1.4, but it's 1.4 exactly. Square root of 2, when I put in the calculator, is 1.4142 and blah, blah, blah. So that means there is no perfect square or number that is the square root of 2. None of these answers are a solution to this equation. This is what's called an irrational number. An irrational number is a number that doesn't repeat and it doesn't terminate, that means end, okay? And the most common irrational numbers are square roots of non-perfect squares. And 2 is a non-perfect square. So something like square root of 10. Well, I don't know a number times itself that equals 10. Square root of 15. Those are all irrational numbers. So this is your first introduction to a little bit of this. We'll define it fully at the end, but at this point, okay, like I said, usually go ahead and pause this video if needed to kind of process some of the information we just talked about. All right, let's resume. All right, you do not have to write this down just yet, okay? But a rational number, the official definition is that a rational number is a number that we can write as a fraction. But A and B must be whole numbers or integers. That means it could be something like 3/2, but it can't be something like 3.1/2 because 3.1 is not an integer. So we can't just go ahead and arbitrarily have numbers in the numerator and denominator. A rational number must still have an integer or whole number in the numerator and denominator. It can be positive or negative. So that's basically what a rational number is. So our next activity, I'm going to have you practice creating fractions. Some of it you can do on your own. Some you need to use a little bit of technology. So on your graphing calculators, I'm going to show you how you can convert numbers to fractions if you don't know that already. Okay. So let's zoom a little bit to page, and let me scroll here, page 195, okay? Go all the way to page 195, please, and just pause there. You don't have to start anything just yet, because I'm going to go back a slide in a moment. Go to page 195. All right, here we go. Before we start that activity, let me just show you a few examples on how we can convert these. So just like you can see in bold up there, rational numbers can be put as fractions. It's kind of like saying ratio. That's what's in bold right there. Ratio. It can be put as a ratio. Here's a bunch of examples. But you do have to simplify them. Like square root of 9 is 3, which is also the same as saying 3 over 1. That is a fraction because they're both integers. In the last expression, it's negative square root of 16 over square root of 100. That's the same thing as saying negative 4 over 10, which is the same thing as saying negative 2 over 5. That is a fraction once we simplify it. So as long as we can simplify it and make it a fraction, we're good to go. Now, I also notice right here, 0.2. 0.2, some of you may know what the fraction version of this is, but that is a little bit more awkward. It's not something most people memorize. Okay? So if we want to use our calculator to do it, let's do it together. So take your calculator out. I'm going to ask the calculator to convert a number. To do it, you're going to type in 0.2. Go ahead and do that. Type in 0.2 on your calculator. Don't press anything. And now press math button. It's right underneath the green alpha button. Hit math. And the first option says arrow fraction. So on your calculator, it should look like this. 0.2 arrow FRAC. Hit enter and look at that. It turns it into a fraction, which is 1/5. If it can be converted into a fraction, it will. Some numbers can't. For example, just before I told you square root of 2 is an irrational number. I'm going to put that into the calculator and use that fraction command to see if it'll convert it into a fraction. So I'll put square root of 2 and then go math fraction, and it gives me 1.41 blah blah blah. It cannot convert it to a fraction, therefore it just gives us the simplification in decimal form. So at this point, that gives you another tool to convert numbers, decimals, to fractions. That's how you prove if they're rational. So let's try some. On page 195, there's a bunch here. Okay, it says rational numbers are fractions and they're opposites. All of these numbers are rational numbers. Show that they're rational by writing them in the form a over b or negative a over b. That means make them as a fraction. The only one you can skip is e. It's a little bit of an obnoxious number. All right, I want you to use your calculator or your own general number sense to convert all of these to a fraction. Please go ahead and pause this video. All right, students, welcome back. So you should see that I got the answer key up here. Now, generally, as you're going through this, we already did A, 0.2, it's 1/5, but something like B, you do have to simplify it. Negative square root of 4 is negative 2, and if I put it over 1, it's a lovely looking fraction. For C, it doesn't have the repeating symbol, so I would have used 0.33 and the fraction command in your calculator, and it would have spit out 333 over 1,000, though some of you might have been able to convert that without the need. And then for D, don't forget that's a cube root. We've used cube roots when we were studying volume. You can get this cube root button by hitting math button. If you hit the math button on your calculator, there's the cube root command on option 4. And then for F, you don't need a calculator for that. Square root of 1/9 is 1/3, and you now can prove that it's a rational number. So at this stage, this right here kind of gives you a look at different rational numbers. That's all. It's just proving that they're rational by making them a fraction. So one other fun fact about rational numbers is they are also decimal representations. So on page 195, look at 2. We're going to just do a couple of these because most of you can handle these pretty quickly. To find the decimal, we just got to divide them out. So 3/8, I would do 3 divided by 8, it's 0.375. And even going all the way down, I'm just going to skip around. We don't have to do a lot of these. Like for D, it's 55.5. It's just dividing the fractions out to get the decimal. It's giving you both versions of a rational number, decimal and fraction equivalent. So that's everything related to rational numbers. We need to be able to say they can be put as a fraction, and including converting it back and forth between a decimal and fraction. So going back to that square root of 2, no fraction actually exists for square root of 2 because it is an irrational number. So that is how we define an irrational number. You cannot create a fraction from it. So some of the more common ones are non-perfect squares, like square root of 10, square root of 15, anything that is not a perfect square. So going back to that square root of 2, 7/5 was the closest, but you can see on the number line, it is not exactly square root of 2. So therefore, it is still considered irrational. All right, hopefully I hammered this point home. We are going to lock it into some full notes here. So take out your notes, or in the back of your notebook, you can do this. Okay, take out your notes in the back of your notebook. All right, I want you to write down the full definition of rational and irrational. Okay, the only thing down here where it says square roots for irrational, I put perfect pairs. It's just another terminology. I'm going to change it to square here just so it's a little more common with what I was saying today. All right, go ahead and pause this video. Get this into your notes, please. Okay, and get prepared for the cool down. All right, so here's your cool down. And what I want you to do with the cool down, all right, teacher is going to pass out a blank sheet of paper. Okay, so there's some blank sheet of paper at the very front. Don't use the big sheets. Use those half sheets, quarter sheets that I cut up already. And put your name on it and label it cool down 3.5. I want you to answer 2 questions. In your own words, say what a rational number is. Give at least 3 different examples in your own words. Don't copy the notes, please. And question number 2, in your own words, say what an irrational number is. Give at least 2 examples. So once you have finished that, okay, once the whole class is finished, we're going to go ahead and collect it and clip it, and I'm going to review it just to make sure that you hit the target for today. So once everyone has finished that, okay, pass them forward or have someone go around and pick them up, and then I'll talk about the last couple things here in a moment. Please go ahead and pause this video until everyone's finished with the cool down and it's been collected. All right, so cool down should be finished by now. At this point also, you should get a half sheet that looks similar to what's on the screen. If you don't have it, please go ahead and get someone to pass it out to everyone. All right, so here's what this sheet is. This is a reference guide. This is part of your notes. It is not going to be collected. It is not homework. It's part of your notes. So you can work on this in class today or afterwards during if you don't have enough time. Basically, it's a reference sheet. So for example, if I give you something like 4 squared, the perfect square would be 16. The square root would be square root of 16, and the term would be 4. Technically, you should memorize everything from 1 to 20. This is a reference guide, and it's going to be very helpful for tomorrow's lesson where we have to estimate imperfect squares like square root of 10, square root of 67, anything that's not a perfect. So I gave you the example for 4. There's other ones. I'll give you a couple more, like say 20. It's 400. Square root of 400 would be the 3rd column, and then the term would actually be 20. So at this point, most of you can kind of see the patterns involved here. Okay, the expectation is that you hold on to this for as your notes, and that you start looking at it and memorizing many of them. This is going to serve as a little bit of my challenge system. So once we have gotten through the first couple days of this unit, I will start randomly asking you guys some of these, like, hey, who knows 17 squared? And if you can say 289, then you can earn something for achieving the challenge. The Quizlet link, there is a Quizlet link in Schoology if you want to get the answers. Of course, you can use a calculator or other things too, but there is a Quizlet link for you to just kind of practice on your own if you want. It's not required, but it's available as an extra resource. All right, so with that being said, that's one thing you should do during the remainder of this hour. The second part is homework number 104 is 121 to 122. It's questions 1 through 5. You can skip number 6, please. So that concludes this lesson video. Go ahead and rewind, review, or anything that you need, but at this point, it is work time the remainder of the hour. Please remain in your seats, stay focused, and we will resume tomorrow with the next lesson.